Now, let's have a look with the hyperbolic version of the secant. You might want to try with the way that you are doing with the integral of secant x. But for this one, we are going to approach like that, kind of, you'll see. Anyway, this right here is the integral. For the hyperbolic secant, this is just 1 over cos x, that's okay, dx. And now, the problem with this one is that we do not have the top to be sinh x to help us out. So do not try to do u sub right now. It's not going to help yet, right? Well, we want to have more things to work with. Just like the traditional version, when you have an integral, sine and cosine, they are best friends. When we have the hyperbolic version, sinh and cos, they are best friends. If we have cos right here now, we want to produce sinh to help us out. And to do that, in fact, I'm not going to multiply sinh on the top and also on the bottom. Because on the bottom, if I have sinh x times cos x, well, that's an identity that I don't know if that will be any good for us. So I will actually multiply this by cos x on the bottom and also on the top, because that way I can produce cos square x on the bottom, and we do know a much better identity to help us out for that. Well, have a look here. This is the integral. On the top is cos x over. On the bottom, notice that this is just cos square x. And let me write this down right here for you guys. Recall that cos square x minus sinh, this is nh, square x. This right here will give us 1, right? And of course, we can just add this on both sides. So we can say cos square x is equal to 1 plus sinh square x. Much better. I will put this down right here, and you see we still have what? This right here, we still have the sinh and cos. That will help each other out. Very nice. And I will just put down the dx right here. And then, of course, we can do u sub. I'm going to let u equal to just sinh to the first power. And the reason is because when I differentiate this, I will get positive cos x, and you see this is just to the first power. This right here, it's exactly what we have on the top. That's the du right here. Very nice. So now this is the integral. I figure I should also put the du right here just to be consistent. But anyway, this right here is the du. I'll put it on the side, and here we have 1 on the top over 1 plus sinh is our u, so I'll just put on u and then square that, and then all this is the du. Now, when we integrate 1 over 1 plus u squared in the u world, this right here gives us the inverse tangent. Notice this is the original version, okay? The inverse tangent, the regular version, right? The original version. And the input here is u, like this. However, u is sinh, so I'll just put that down. So in the end, we have inverse tangent of sinh x, like this. And with that, we are done. So this is it.